the number of feasible solutions of a LPP. So we know that after obtaining the feasible region, so all the points inside the feasible region forms the solution of the linear programming problem. You can clearly see x plus 2y is less than 120. So let us take the values of x and y as 0. Then here, if I take x 0, y 0, 0 is less than or equal to 120. It's a true statement. I said the area containing 0 is the feasible solution. That means for this line, the area should be below the line. Everyone, a warm welcome to one and all. This is Shruti ma'am lecturing in Vidyashram, the Temple of Excellence, Mysuru. Here in this session, we are going to revise the chapter Linear Programming Problem. So we know that it is very important under part E section, that is for 6 marks. Now let's see the weightage of this chapter. So you will be having one MCQ and one 6-mark question. So that is the graphical method of solving the linear equations, and overall you can expect 7 marks from this chapter. So let's take the objective questions. In a linear programming problem, the objective function is always cubic, quadratic, linear and constant. So clearly we know that the linear programming problems is basically on linear functions. So therefore option C is the right answer. The corner points of the feasible region determined by the system of linear constraints are 0, 0, 5, 0, 3, 4, 0, 5. The maximum value of the objective function z is equal to ax plus by is occur at both 3, 4 and 0, 5. Then the condition for a and b is a equals b, a equals 2b, a equals 3b, b equals 3a. Let's check. So this is our objective function and they have given the maximum occurs at 3, 4 and 0, 5. So what happens when this is 3, 4? That is z is equal to 3, 4 and 4, 5. So when it is at 3, 4, then it is 3a plus 4b. And another thing is z is equal to 0 into a, which is 0, and we have 5 into b, which is 5b. Since both have the maximum value, their value should be equal. That is 3a plus 4b should be equal to 5b. On solving this, we will get 3a is equal to b or b is equal to 3a. Hence, the option is b is equal to 3a. Next. The number of feasible solutions of a LPP. So we know that after obtaining the feasible region, so all the points inside the feasible region forms the solution of the linear programming problem. And hence if they ask us to find the number of feasible solution, that must be infinite. So options are here 1, 2, finite and infinite. So the correct options is infinite. Next. The corner points of the feasible region determined by the system of linear constraints are 0, 0, 0, 50, 30, 0, 20, 30. The objective function is z is equal to 4x plus y, then maximum value of z. So let us find what is z at all these points. Now for the first one, at 0, 0, z is equal to 0. Now for the second one, z is equal to 0 plus 50, which is 50. For the third one, 12, 120 plus 0, which is 120. For the fourth point, it is 2 4s are 8 plus 30. So z is equal to 110. So the options are given here 210, 150, 110, 120. So the correct option is D, 120. Next. Corner points of the feasible region determined by the system of linear constraints are 0, 3, 1, 1, 3, 0. Let z is equal to px plus qy, where p, q greater than 0. Condition on p and q so that the minimum of z occurs at 3, 0 and 1, 1 is p equals 2q, p equals q by 2, p equals 3q, p equals q. So since the minimum of z occurs at 2 points, then their values of z must be equal. So therefore, at a 3, 0, so z will be equal to 3p. And at 1, 1, z will be equal to p plus q. So if we equate them, 3p is equal to p plus q, then we have 2p is equal to q, or we can say p is equal to q by 2. So the correct option is option B, that is p is equal to q by 2. Next. Now we are studying a very important questions, that is the minimizing or maximizing the linear programming problem. So here, which is for 6 marks. We know that under party section, we will be having 2 questions on 6 marks, that is LPP and integration. So if you are thorough with LPP, then you can skip integration under 6 marks. Then you can find the graphical method using linear programming problem. So here we have the question, minimize and maximize z is equal to 5x plus 10y subject to the constraint x plus 2y less than or equal to 120, x plus y greater than or equal to 60, x minus 2y greater than 0 and x comma y greater than 0 by graphical method. So here this clearly says the solution lies on the first quadrant. Now let us solve these linear equations. So we have x plus 2y less than or equal to 120. So if I write the coordinates of x comma y here, so since it is less than or equal to 120, if I take x as 0, then y is 60, and if I take y as 0, then it is 20. So therefore the coordinates is 0, 60 and 120, 0. So next we have x plus y greater than 60. So x plus y greater than or equal to 60, we can also take equals while taking coordinates. So x and y, if I take 0 and y is 60, y 0, x is 60. So therefore it is 0, 60 and 60, 0. Next we have x minus 2y greater than or equal to 0. X minus 2y is equal to 0 also we can take, which can be written as x is equal to 2y. So if I take the value of xy here, so let me take x is equal to 0, then y is equal to 0. Let me take x is equal to 40, then y will be equal to 20. So therefore the values is 0, 0 and 40, 20. So now we can take all these points along x and y axis by plotting in tens like 10, 20, 30, 40. Similarly, we can take along y-axis. So if you plot all these values in graph, then it looks like this. So here we can clearly see 10, 20, 40, 50, 60, 70, 80, 90, 100. So this is how we will get. Now coming to the feasible region here, you can clearly see I have already shaded the feasible region. But how to find the feasible region for each lines? So first, once you draw the lines, write the equation of the given lines. For instance, for this line, this is x plus y 60, and for this line it is x plus 2y is equal to 20, and this is x is equal to 2y. So by considering the conditions of linear programming constraints, you can clearly see x plus 2y is less than 120. So let us take the values of x and y as 0. Then here, if I take x 0, y 0, 0 is less than or equal to 120. It's a true statement. That means the region of this line should be the region where it contains 0. Hence, for this line, we have to shade the region below the line. Next, we have x plus y greater than 60, which means 0 greater than 60. It's a false statement. So therefore, we can clearly see, so this is not the solution. That means we cannot shade the region where it contains 0. We have to shade the region which does not contain 0. So therefore, for this line x plus y is equal to 60, you should shade the region above the line. Next, we have x minus 2y greater than 0. 0 greater than or equal to 0. So since 0 is equal to 0, it is a true statement. So that means the solution contains 0 among the line. So since we need greater than 0, it has to fall below this line. So therefore, we can clearly see we have 4 regions here. The only region which satisfies all the linear constraint is this. Once you find the linear constraint, mark the corner points or the vertices of the quadrilateral here. So mark the points. So here A is 60, 0, 120, 0, C 60, 30, D 40, 20. So once you have marked the corner points, let us find the value of z at corner point table. So this is how we'll get corner point and the z is equal to 5x plus 10y, which is a linear function. Just find the values of x and y, substitute in z and calculate the value of z. So from the corner point table, we can see at A it is 300, at B it is 600, at C it is 600, at D it is 400. Since we need to find both maximum and minimum value here, so we can conclude the statement that is the maximum value of z, that is the maximum value of z is 600. Since the solution is more than at one point, we'll write maximum value of z is 600 at the line joining or at the line segment, joining B 120, 0 and C 60, 30. So this is how we'll write the solution for maximum or minimum when it exists at more than 1 point. Next, we need to find out the minimum value of z. So minimum value of z clearly is 300 at the point A 60, 0. We'll take one more example. Minimize and maximize z is equal to 3x plus 9y subject to constraint x plus 3y less than 60, x plus y greater than or equal to 10, x less than or equal to y and x comma y greater than or equal to 0 by graphical method. So just find the solutions for these equations. So if we find the solution for x plus 3y is equal to 60, then we'll get 2 points, that is 0, 20 and 60, 0. So we can plot this line using along x and y axis. And here also if we get x plus y is equal to 10, then the points are 0, 10 and 10, 0. For the third equation, we have x is equal to y. So we can take any 2 points, for example, 0, 0, 10, 10 or 20, 20, anything. So that will be the solution of this line. Now for shading the region, see the condition, take x, y, 0. So then 0 less than 60, it is true. 0 greater than or equal to 10, it is false. 0 less than or equal to 0, it is true. So if you draw a line for this equation, then a region containing 0 is the feasible region. And for this line, the region does not contain 0 is the feasible region. And for this line, the area behind the 0, for that line, the area behind the 0 will be the solution since we have less than or equal to. So for the given linear programming problem, so this is how we will get the graph. So we can see all the points here. So this is the equation of line x plus y equals 10. So for this equation, and this is one more equation, that is x plus 3y equal to 60. So this is the equation of line of x is equal to y. Now for the first line, I said the area containing 0 is the feasible solution. That means for this line, the area should be below the line. And for this line, the area does not containing 0. So therefore, it has to be here. And for this line, 0 is less than 0. Therefore, the solution lies behind the line. So the only region which satisfy the given condition is this region, A, B, C, D. Once you got the corners, write the corner points as A, B, C, D, that is A 0, 10, B 5, 5. So you can verify this through graph and C 15, 15, D which is 0, 20. After finding the corner points, substitute in the corner point table, evaluate the value of Z as 3x plus 9y. So once you substitute x 0, y 10, you will get 90 here. 5, 5, you will get 60. For 15, 15, 180. 0, 20, 180. So here also you can see maximum occurs at 2 points. So therefore, maximum value of Z is 180 at line segment joining C and D. That is C 15, 15 and D 0, 20. Similarly, the minimum value of the linear function is 60 at the point 5, 5. So this is how we will find the maximum or minimum value of the given linear objective function. We'll meet you in the next session with a new chapter. Until then, keep watching, keep learning, keep exploring. Thank you.